Hello, I am Professor Alan Perry, and in this video series I will explain to you the noble science and marvelous art of trigonometry. Hey! Wow, that guy was boring. Actually, I'm Alan Perry, and in this video series we will explore trigonometry, but not in the stuffy way that some guys think of it. No, I believe that mathematics is the stuff that rock stars are made of. Seriously, Johnny Buckland from Coldplay has a bachelor's degree in mathematics. Art Garfunkel, yeah, the one from Simon and Garfunkel, has a master's degree in mathematics education. And Brian May from Queen, he studied math and physics in college and almost got a PhD in astrophysics. I mean, I think that sort of makes me a rock star, right? Right? Anyway, in today's episode, we introduce you to trigonometry by discussing the main concept that trigonometry is about, and that's angles. Angles are literally everywhere. You can find them in engineering, construction, carpentry, architecture, sports, art, physics, chemistry, surveying. We even use them figuratively when talking about how we present a story, whether it be fiction, journalism, or otherwise. Of course, the only real journalism with the right angle would be this one. You get it? It's funny because it's 90 degrees. Just roll the credits. To talk about angles, we need to know what one is, and that starts with the concept of a ray. No, not that kind of a ray. What I'm talking about is essentially half a line. If you take a line and pick a point on it, and then remove the part of the line that is on one side of that point, the result is a ray. Another way to think of a ray is to start with a point and move away from that point in a single direction, tracking your path behind you. This is kind of like a ray gun shooting a ray out of it. Huh, I wonder if that's why they call it a ray gun. Anyway, an angle is made out of two rays that shoot out from the same vertex. See, right there. The vertex is the common starting point of the two rays. And the measure of an angle measures how far apart the rays are. We measure this by looking at the fraction of a semicircle that is between the two rays. So consider a semicircle. The entire semicircle is between the two opposite rays that make up the diameter line, with vertex at the center of the circle. If we cut up this semicircle into 180 equal parts, 1 degree is the measure of the angle that contains one of these 180th parts of the semicircle. No matter what size semicircle you make, this 1 degree angle will always sweep out 1/180th of that semicircle. Notice that 1/180th of a semicircle is 1/360th of a full circle. So another way to think of this is a 1 degree angle sweeps out 1/360th of a full circle. And that's why there's 360 degrees all the way around the circle. The number 360 comes from the number system used by the Babylonians. They favored this number because it has so many integer divisors. For us, this means that a lot of different commonly occurring angles will be nice fractions of 360 degrees, and we'll have angle measures that'll come out to be a nice integer. In fact, we continue to use multiples of 60 to cut up the degrees even more. 1 arc minute is 1/60th of a degree, and 1 arc second is 1/60th of an arc minute. Rather than a decimal degree, angles can be given very accurately using degrees, minutes, and seconds, or DMS measure. For example, an angle that has a measure of 63 degrees, 32 minutes, and 46 seconds refers to the angle here. Whether a decimal representation of a degree or the DMS is used varies according to profession. Now, before we can use angles in practice, we need to identify a few more ideas about them. One issue is that if an angle measures the separation between two rays, we could ask whether we mean the short separation or the wide separation in an angle. To help identify which angle we mean, we will call one ray the initial side and the other side the terminal side. Of course, that means that we still can't tell the difference between the counterclockwise angle from the initial side to the terminal side and the clockwise angle between them. To distinguish between those two angles, we first need to understand sine. No, not that sign. That'll come later. I mean, we need to know what positive and negative angles are. What do you think? Can you help us out, number man? Totally. As humanity understood numbers more deeply, the need for negative numbers became more and more apparent, especially since subtraction can be thought of as addition of negative numbers. The oldest references to negative numbers come from China in the 2nd century BC. Gradually, the need for these numbers led to their discovery in other cultures, including India in the 7th century, and eventually becoming mainstream in Europe, who were the first to use the modern signs of plus and minus to depict positive and negative numbers. Today, mathematicians consider the sign of a number to indicate the number's direction. For example, on a number line, positive numbers are typically listed on the right, with negative numbers listed on the left. Adding a positive number means to go right on the number line, while adding a negative number, or subtraction, means to go left. Kind of like moving forward and backward on a board game board. Positive and negative angles mean the same thing, but they denote rotational direction. Positive angles typically are depicted by counterclockwise rotation, while negative angles indicate clockwise rotation. So given the two example rays here, if this is the initial side and this is the terminal side, the counterclockwise angle between them is 300 degrees, while the clockwise angle is negative 60 degrees. Thanks, number man. The last few important ideas about angles that we need to know are just a few words that will come up frequently in our study of trigonometry. The first is the notion of an acute, right, obtuse, and straight angle. A positive angle is called acute if it's smaller than 90 degrees. You know, it's an acute little angle. A right angle is an exactly 90-degree angle. An obtuse angle is an angle whose measure is between 90 degrees and 180 degrees. A straight angle is an angle of exactly 180 degrees. That is, the two rays that form the angle also form a straight line. Next is the idea of complementary angles. Now, I know that the idea sounds like the angles are particularly polite, but it really means two positive angles whose angle measures add to 90 degrees. This means that both of these two angles are acute. So I guess you could think of it as two little acute angles being polite to each other. Still nothing? Finally, there's also supplementary angles. These are two positive angles whose angle measures add up to 180 degrees. So they kind of supplement or complete each other to a straight angle. You complete me. Yeah, okay. That was a little obtuse. I'll stop. Anyway, now that we have a good understanding of what angles are and how to measure them, next time we'll talk about one of the most important shapes in mathematics and the foundation of trigonometry, the triangle. I hope you'll join us. And if you haven't already, please remember to like this video and subscribe to Scholar Sauce. Oh, and tell us in the comments if you have any really good angle jokes. I can always use some new material.